All right, so let's assume for a second that we wanted to make an artillery game where we've got two cannons trying to shoot over a mountain, or a lunar lander game, or a Martian lander game, or something like that. I kind of got on this tangent because Mars probe Perseverance just landed. I thought, oh, lunar lander game, sure, that'd be cool. So in a game like that, you're going to have some randomly generated 2D terrain. So how do you randomly generate 2D terrain? There's a very elegant technique called the midpoint displacement algorithm, or midpoint displacement method, and I'm going to show you that real fast, as well as an implementation of it in PICO-8. It's really cool. You don't really have to understand how it works. If you want the code, I'll give it to you, or modify it so you can use it for your own game. But let's take a look at that algorithm and how it works. So imagine that our terrain consisted of a flat plane. The way this algorithm works is we find the midpoint of our terrain, and we raise or lower it by an amount that's proportional to its length. So a longer segment is going to be displaced more than a shorter segment. So what we're going to do is take our terrain, break it in half, and displace the midpoint, move it up or down by a random amount that's proportional to its length. So the first segment is going to be displaced by the most because that's the biggest length. Then we break that segment up, that line up, into a left half and a right half. And we say, okay, apply the midpoint displacement algorithm to the left half and apply that midpoint displacement algorithm to the right half. So then what we do is when we apply it to the left half, we break the left half in half, we find its midpoint, and we displace it by some random amount that's proportional to its length. And because its length is half of the length of that we just looked at, that displacement amount is going to be a little bit less. And the same thing is going to happen here on the right. And then we just repeat. This split here would say, you know what, okay, fine, I want you to now apply the midpoint displacement to my left half and my right half. And the segment on the right here, when we split this, would say, okay, great, now I've been split and displaced, now I've split and displaced the midpoints of my left side and my right side. And we keep doing that until the points are next to each other, that we can't subdivide them anymore. That is, there's many ways to implement this. You can have functions that call themselves, that's recursion. But the way I've done it here is I've done it, it's fun to watch it work. So what I've done is I'm using a timer and a loop. And you'll actually be able to see the algorithm work. So what happens is we have a bunch of lines, we find the midpoint, displace it, then we break up its left half and its right half, and then its left half, we'll say, okay, break up my left half and my right half. So it's going to kind of, the problem subdivides itself until the units of work get so small that they can't be done anymore, that there's nothing to do. All right, so let's go pop over to PICO-8 and take a look at what this looks like. Run. Here we go. So you can see that the biggest displacement amount is in the middle. Actually, part of that is kind of extending off the bottom of the screen, but that's okay. And so there we go. You can see it's just kind of fun to watch it go. Whee! Let's watch it a couple more times. There we go. So the biggest displacement is going to be in the middle there. And then if you wanted to randomize that even further, what you could do is take that whole list of points and you could rotate it. So basically shift the terrain to the right, and any terrain that fell off the right, you'd put it back on the left. You just rotate the elements in the list of points that make up this terrain, and you'll end up with cool random looking terrain. Now you could also you could do this more than once. You could have kind of background mountains. You could have a parallaxing effect. You could have background mountains and foreground mountains, but this is certainly enough to get you a lunar lander game or a an artillery game. So just super cool, super fun stuff. The midpoint displacement algorithm, very cool. Could you apply this to 3D? Absolutely, yes. There it's called the diamond square algorithm. You take a giant square, you find its midpoint, you displace it. Then you break that square up into 4 smaller squares. You find their midpoints, and you displace them. Then you break those squares up into smaller squares, and you can actually generate 3D terrain that way. So yeah, just cool stuff. So yeah, you know, so when you think about, okay, I want to have a game that does this. Okay, great. Well, okay, how are you gonna make the terrain? So there it is, midpoint displacement algorithm and diamond square.